Hello everyone, am I audible?
Yes, sir. Good evening.
Good evening, Krishna, Ronaldo, Sai, Anil.
Yes, sir.
All right, everything good, Sai?
Yes, sir.
All right, did you watch previous lectures? Sai,
Yes, sir.
did you? All right, everything understood, right? No doubts there.
No, sir.
All right, and I hope you guys remember that today is your Viva. So we'll start with the Viva. Let the other students come. All right, we'll wait a few minutes for them. Till then, you can revise matrices and determinant. All right, Krishna, Ronaldo.
Yes, sir.
Yes.
All right. Till then, you can revise. We are waiting for the other students to come. All right, let's start with the Viva. All right, I will be asking the questions. You can send the answers on the chat. All right, Krishna Ronaldo.
Yes,
Clear?
sir.
All right. First question is, if matrix A has 18 elements, then what are possible orders of matrix A? All right, I'll be timing your answer. 60. I'll give you 2 minutes for this question. All the answers should be in chat. Good evening, Shikhani. Shikhani, I'm audible.
Yes, sir.
All right, we are taking Viva, right? I hope you remember. And this is your first question of the Viva. You have to send the answers in the chat. All right. If I don't receive any answers from anyone, then he will be awarded 0 marks. Shikhani, are you sending the answer?
Yes, sir.
All right. I'll give you 2 minutes. All right, Ronaldo, can you answer me this? What is Diagonal matrix. What is a diagonal matrix? Ronaldo, can you answer this?
Yes, sir. Yes, sir. Sir, if there is a matrix and all the like the elements which are not making a diagonal are zero, then it is called diagonal matrix.
All right. Krishna, is it right?
Sir, I didn't listen properly, sir.
All right. You can tell me what is diagonal matrix?
So the matrix in which the diagonal elements, where all the non-diagonal elements are zero, are called diagonal matrix.
All right. And what is identity matrix?
Identity matrix is where the diagonal elements is equal to 1 and all other elements are equal to 0 is called identity matrix.
All right. Shikhani, this is right. The definition of identity matrix.
Sir, can you repeat?
Shikhani, your voice is not audible.
Sir, I was saying, can you repeat?
You are saying what?
Sir, I'm saying, can you repeat?
Can I repeat? I am saying, is it Krishna right or not?
Sir, I couldn't hear you.
I couldn't hear. All right. Let's see. Answer me this. 1 0 0 0 0 1. Is this an identity matrix or not?
No, sir, it's not. It needs to be of the same order.
Right. Shikhani, what is a symmetric matrix?
Sir, symmetric is when A transpose is equal to A.
It transposes A. All right. And Ronaldo is transpose.
Sorry, sir.
What is transpose of a matrix?
Just a minute, I can't recall it. I'll tell you, sir. Just a minute.
All right. After googling.
No, sir, I'm not doing it.
All right. Syed, can you? Yes.
So, like, if there's a matrix and we interchange the rows and the columns, like if the rows are vertical, we make them horizontal. They the matrix we get is known as transpose of a matrix.
What is inverse of a matrix? Do you know this?
I'm not sure about it.
Right. Syed, do you know what is inverse of a matrix?
Yes, sir.
Can you tell me?
Yes, sir. In a 2 by 2 matrix, the positions of 1 1 and A11 and A22 are exchanged. The numbers in these positions are exchanged, and in the numbers in the position A12 and A21, their signs are changed.
And we get inverse.
So,
Do you get inverse by doing that, or what do you get?
yes, sir, we get the inverse of the matrix.
All right. I thought that was adjoint of a matrix, right? For 2 by 2 matrix. Right, Syed? All right. Ishan is here. Everything good, Ishan?
Yes, sir.
All right, your voice is very low, Ishan. You can please check the mic. All right, Shivani, what is adjoint of a matrix? No, Ishan, you are still right. Now I can hear you. All right. Shekhani, what is adjoint of a matrix?
So I don't know about it.
No, no, Ishan, I'm not asking you. I'm asking Shekhani.
Yes, sir.
Sorry, sir. Okay, sir.
Yeah. Can you tell me what is adjoint of a matrix?
Sir, sir, I can show how it is done. But
All right. Tell me if you are given a matrix A, then how to find the adjoint? Tell me the steps.
um, so, for example, if it's a matrix of order two, we'll interchange the
If it
A11
is
by 2 2.
if it is of order 3, then what do you do?
So then we have to calculate that. So you have to calculate each of them. You have to find determinant of each. Then we have to solve it.
Solve it how?
Sir, I can show it, but I don't know how to explain.
Show me how to do. All right. We'll get to that. Krishna, how to find adjoint of a matrix?
Sir, the adjoint of matrix, we take the cofactors of the matrix and then we take the transpose of it, then it is the adjoint of the matrix.
All right. Cofactor. Ronaldo, I don't know what a cofactor is. How to calculate that?
Sir, like we'll take -1 and to the power of uh, uh, the rows and columns. Like we'll make the sum of them and then we'll multiply it with the uh,
You can say it very simply. Whatever you can think in Hindi, English, or whatever language you feel good.
yes, sir. So then we have to multiply it with the minor of them and then we'll get it.
That's absolutely right. So Shekhani, I don't know what is a minor of a matrix. Shekhani, can you tell me what is minor of a matrix?
What's it?
What is minor of a matrix?
Sir, like for example, we'll take A11 and then we'll multiply A22 into A33 plus A23 into A32.
All right. Is it right, Krishna?
Sir, I'm not sure.
I'm not sure. Right.
Sir, we'll take the determinant of this. Sir, I don't know how to explain. I can show it. I can
You
show it.
can explain to me like I'm a 3-year-old. Just tell me how to do that. Whatever you do, whatever you can think of. All right.
So, for example, if it's a matrix of order 3, then I'll take A11 and delete all the row of that and the column of that, and the rest I'll take the determinant.
Right. That is all I want to hear, right? I don't need pretty definitions. I need to know that you can calculate things, right? That is all my job is. All right, then it is good. Who can tell me this formula? What is this formula? Adjoint of adjoint of A determinant. How to calculate this? Answer me in chat. All right. 2 minutes for this. I only have received only one answer. All right, time is up for this question. Next question. This question is matrix. Sorry.
So we have to send these to you, like everyone, or so only one person.
Shikhani, your voice is breaking or not clear.
Sir, we have to
Cannot.
send this to you, the answer.
Right, this answer you have to send me on chat. Right, this answer all you have to send me on chat. This question is cos alpha minus sin alpha cos alpha. Okay, they are saying A plus A transpose is equals to I. Find alpha. All right, this question is 2 minutes for this question. And Ishan and Syed, you can try solving this. All right, if you cannot, then no issue. But you can try this, right?
Yes, sir.
And again, I need the answers in the chat.
Sir, is the answer correct?
I received the answers of all the people. Two are missing. Next question. Ronaldo, I asked alpha, not cos alpha. Next question. If A is a square matrix, such that A square equals to A, then write the value of 7A minus I plus A whole cube. Where I is the identity matrix. This is your last question. You can send me the answer in the chat. All right, I got everyone's answer. And Shekani, you can check if that is I or minus I.
Sir, it's I am using.
All right. All right, your Viva is done. So let's start where we left off. Ishan, did you watch previous lectures?
I asked them for the previous lectures, but they said that you will send in some day.
What will we do?
I asked them
What did they say?
for the lectures, but they said that you will be once they add me to a class, then I will get the lectures.
All right. No worries. So let's start today's class. Everyone, any doubts from the last classes?
No, sir.
No.
Sir,
What
is the last answer of mine correct, sir?
Your last answer is yes, that is correct. Shekani, what is equivalence relation?
So equivalence relation is a transpose. Sorry. Equivalence relation is a relation which is reflexive, symmetric, and symmetric, and transitive.
All right. And what is the reflexive?
Reflexive is the one that reflects itself. For example, A, B, B.
All right. What is symmetric?
Symmetrical example is 1, 2, and 2, 1.
All right. What is transitive?
Transitive, for example, 1, 2, 2, 3, and 1, 3. But it can also have a special case. If there is nothing to compare with it, it can also be called transitive.
Right. All right. So everyone is clear about this. Shekani explained this very clearly. All right. So let's solve one question. Few more questions on this. Then we'll end this topic. Write down. Show that the relation R on the set A of points in a plane given by R equals to PQ such that distance of the point P from the origin is same as distance of point Q from origin. Is an equivalence relation. Further, show that the set of all the points related to a point is not equal to 0, 0 is the circle passing through P with origin as center. All right, this question is clear. I hope. Try to solve this. I'll give you a few minutes. The question is clear to everyone, right? Everyone?
Yes, sir.
All right. Ishan, Shikani, Krishna. Krishna is okay. Ronaldo.
Yes, sir. Clear.
All right. Ishan.
Yes, sir.
All right. Said, the question is clear.
Yes, sir.
All right. Shikani, what about you?
Yes, sir.
All right, then you can try solving this. After that, I'll explain how to write the complete answer. All right. Whenever someone is done, please text me or tell me. And give me 2 minutes. All right, guys. I'll be back in 2 minutes. Anyone done with the question?
No, sir. So much to write. That's why.
Almost done. All right. I'll give you 2 more minutes. Right, Shikani? That are very good points. All right. You don't have to send me the answer, Shikani. That's all right. Krishna?
So this is not part of the test.
No, no, no. This is not part of the test. Viva is over.
Okay.
All right. Yeah. Krishna, have you solved this?
Yes, sir. The last transitive part I'm doing something, sir.
All right. Ishan,
Yes, sir.
have you solved this?
No, sir. I'm trying.
No. Trying. All right. Ronaldo,
Yes, sir. So
solved. All right. Syed,
No, sir, I'm doing.
All right, you guys see, it's okay if you cannot solve this, right? No one is giving you punishment for this. Take your time, think about what you do in this type of questions, right? They're telling you to show this is equivalence relation. That means you already know they are all three. All three means reflexive, symmetric, and transitive. So what do you have to prove for this to be reflexive? And what do you have to do for this to be symmetric and transitive? This only you have to think and write this beautifully. That is all the question is asking from you.
Done, sir.
All right. Anyone else? No? Let's see how we can write down the next answer. How to prove reflexive? Ishan, how can we prove reflexive? Can you help?
When first the first side is equal to itself.
Absolutely right. All the elements should be related to itself. All right, so we can write let P, this is not equal to 0, 0, be a point on the plane. All right. So we know that distance of P from origin is equals to the distance of P from the origin. Right? OP is equals to OP. This implies that P comma P belongs to R. Right? The distance of P from origin is equals to distance of P from origin. So P comma P belongs to R. This implies that R is reflexive. This is clear? So symmetric. Krishna, how to prove this is symmetric?
Yes, sir. So let P comma Q belong to R.
All right.
And this implies that OP and OQ are equal.
And you have to mention that OP is the distance of P from origin and OQ is the distance of Q from origin, right?
Yes, sir. I mentioned that at the beginning, sir. So
All right. Yeah. Everyone write down this line also, where OP and OQ are distances from origin. Of P and Q. All right. After that, Krishna.
so then OQ is equal to OP.
Absolutely right.
This implies that Q comma P also belongs to R. Therefore,
Absolutely.
P and Q are in the same distance away from the origin, and R is symmetric.
All right. This means R is symmetric. This is clear, everyone? Everyone, this is clear. Ronaldo, Ishan, Syed,
Yes.
Chitani. All right.
Yes, sir.
All right. transitive? Who wants to tell me how to prove transitive? Ishan, how to prove this is transitive?
Sir, A comma B, then B comma C should be, and then A comma C should be equal.
Right. No, see, you have to think this very carefully and write very carefully, right? Even if you know the answer, you have to write carefully. So you have to write A comma B, let A comma B belongs to R and B comma C belong to R, right?
Yes, sir.
Ishan, you are saying the same thing, but if you don't write like this, marks will be taken out of your answer. All right. Now what we can say?
Sir, we should prove that A comma C belongs to R.
Right. So how what we can write from this? See, if A comma B belongs to R, that means distance of A from origin equals to distance of B from origin, right? This is clear.
Yes. Yes.
And because of that, we can say OB equals to OC also.
Yes, sir.
And this implies that this, suppose this is equation 1, this is equation 2. So from equation 1 and equation 2, we can say OA equals to OC, right?
Yes, sir.
In one line also you have to write OA, OB and OC are distances from ABC from origin respectively. All right, you have to write that line also. So this implies that A comma C also belong to R, right? Because the distances are equal. Now A comma B belongs to R, B comma C belongs to R. This implies A comma C belongs to R. So this is transitive. R is transitive. All right, everyone, this is clear?
Yes.
Yes, sir.
All right. So R is an equivalence relation. Now the second part, they are saying prove that this is the set of, or this is a circle. So what we can do, let P not equal to 0, 0 be a fixed point. And Q be a point such that P comma Q belongs to R. This implies that OP equals to OQ, right? And this, if P is the fixed point and OP is equals to OQ, where Q can move around, this implies that Q satisfies the condition where the set of points Q is a circle, right? In a fixed point, if you calculate the equal distances, then we get a circle. That is the definition of a circle. So we can say that this is a circle. All right, everyone, this is clear?
Yes, sir.
Yes, sir.
All right, new students, Ishan, Said.
Sir, can you explain the
Yes,
second
sir.
part?
The second part, Ishan.
We already proved it's a circle.
All right, Ishan, can you tell me the definition of a circle? Class 9th.
A closed surface without any edges, corners.
All right, and there was another definition, right? There is a fixed point, the collection of points which is equidistant from this fixed point is a circle, right?
Yes, sir.
The fixed point is called center and the distance is called radius. This is the definition of class 9. We use this definition for proving that this is a circle. We said let P be a fixed point. P be a fixed point. All right, so this is P. Now we said Q be a point on plane. Right, so Q can move around in a plane, right? We did not say anything about Q. Q is not fixed, P is fixed. Now we said Q be a point on plane such that P comma Q belongs to R. Now if P comma Q belongs to R, that means OP equals to OQ, right? And Q can move around. Now
Yes,
this is the condition of circle, right? Because distance of OP and OQ are equal and P is the fixed point. So if we have to prove that this is equal to this point and this point is moving around, then this must be a circle, right? Because the fixed point and the distance are always equal.
yes, sir.
Now is it clear, Ishan?
Yes, sir.
All right, you can note in the solution, everyone. Shikhani, this is clear? Shikhani,
Yes, sir.
all right. Do you sometimes go and watch TV or something like that between the class, Shikhani?
Sir, the TV is away from my place. It is in the other house.
Write down the solution, then we'll solve another question. Done, everyone?
Yes, sir.
Yes, sir.
Now a very different question. All right. Think about this question and tell me if you can solve this or if you get the idea how to solve this. This is a very different question. Prove that the relations R on the set n cross n defined by A comma B related to C comma D such that A plus D equals to B plus C for all A comma B comma C comma D belongs to n cross n is an equivalence relation. Also find the equivalence class two comma 3 and 1 comma 3. Write down the question. Think about this. And if anyone tells me what is the difference between this question and all the questions we have done till now, then he will get a chocolate from me, 20 rupees chocolate. Alright, dairy milk silk of 20 rupees.
Sir, for all,
For all, this is A comma B comma C comma D belongs to n cross n.
So what is the last word? Also find the equivalence class.
So find the equivalence class. This is 2 comma 3 brackets and square brackets. Right? In class we always write this equivalence class of 1, equivalence class of 2. So equivalence class of 2 comma 3 and 1 comma 3. All right.
so the equation is A plus D is equal to B plus C.
A plus D equals to B plus C. A plus D is equals to B plus C. Andhra Pradesh, Delhi, Bombay, and Chennai. Everyone wrote down the question?
Yes, sir.
Yes, sir.
All right. Can anyone explain me what they are saying?
So we should prove that it is an equivalence relation and find the equivalence class.
That is right, Krishna, right? That we all know, I think. But what? What is the difference between this question and all the questions that we have done so far?
So I think that A comma B related to C comma A.
Right. So why is that the difference? Why
So
is
I
it
think
different?
he gave it in the condensed form or something. We must express it more clearly.
All right. Anyone else have any answer?
A comma B belongs to R. It's A comma B belongs to C comma A.
Some you are getting some ideas. Think about the previous questions. All right. What we wrote in the previous question, we always wrote A is related to B. Right? Here we have written A comma B related to B comma C.
Yes, sir. We are finding the relation between the ordered pairs.
Right. Right. So how we can do that?
So by the equation given, right? A plus D is equal to B plus C.
Right. But if we were saying A is related to B, we are taking the relation on a set A, right? And A comma B, the ordered pairs we used to find from A cross A, right? We used to
Yes,
write
sir.
A cross A, then take all the ordered pairs that satisfy this condition. Suppose any condition, A plus B is equal to 4. But in here, where would you take the ordered pairs from? Anyone getting what I'm asking, or is it all in the air? Shikhan,
Yes, sir.
are you getting what I'm saying?
Yes, sir.
All right. See, let me explain what I'm saying again. Everyone wrote down the question, right? I cannot
Yes.
go up and down again and again. All right. See, if we had a set A, equals to 1, 2, and 3. All right. And somebody says there is a relation R A related to B such that if B equals to 3. All right. And R on set A. If they said this means we have to take A cross A. So what is A cross A here? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Right? This is the first thing we need to do. We have to find
Yes.
A cross A, right? All the ordered pairs. Now we have to look which ordered pair satisfy condition, right? So 1, 1 plus 1 is not equal to 3. This is wrong. 1 plus 2, yes. So in R, give me a minute, guys. The pen is not working. Wait a minute. Give me a moment, everyone, please. This pen is not working. All right, till then you can try solving this. I can give you a hint how to solve. See, n cross n. They are saying R is on set n cross n. That means here set A is n cross A. All right. So this set R is on set this. So if they are saying R is on set A cross A, that means you have to take double cross, right? You have to make ordered pairs out of these ordered pairs. That is why we have 4 elements in the relation AB and CD. Is it clear what I said?
No, sir.
No. Then give me 2 minutes. All right, let me just check why the pen is not working. All right. This is working now. All right. Everyone there?
Yes, sir.
All right. They are saying R is a relation on set n cross n, right? Till now we have done questions where R is on set n, and if they say n, then we try to figure out n cross n, write all the ordered pairs and think which ordered pair satisfy the relation, right? But here they are saying R is on set n cross n. So this is a single set according to the question. Is this clear now what I am saying? Instead of A, R is on set A, they are saying R is on set n cross n, right? So
Yes,
this
sir.
is all the natural numbers. So n cross n will be 1, 1, 1, 2, 1, 3, and so on, and 2, 1, 2, and so on till infinite, 1, infinite, 2, and so on, right? This is the single set A. If relation is on set A, that means we have to figure out A cross A, right? This is we always do. We try to write A cross A. Now this is set A. So in A cross A, we have to make pairs out of these two. So this will be 1, 1, and 1, 1. This will be one single pair, right? This is clear, everyone?
Sir, can you explain that second part again?
All right. See, in here we had A is equals to 1, 2, 3, 4, 5, and 6, and so on, right? So when finding A cross A, you wrote 1, 1. How did you know to write this, Krishna?
Sir, because of the relation mentioned, like
Right.
A is related to B in that manner.
Right. But how did you know 1, 1 would be there? Why not 1, 15? Why not 1, 2000, and so on? How do you know the first element will be 1, 1?
So because it satisfies the equation first, and
Right? When trying to find Cartesian product, what we do? We write the set 2 times. Again, we let 1, 2, 3, 4, 5, dot dot infinite. Now, when finding A cross A, we take this first element and this first element. So 1, 1 is there. Right? Cartesian product is the ordered pairs of all the elements related to each everyone, right? Now we take the first element and the second element. So 1, 2. First element, third element, 1, 3, and so on. Now we take the second element and first element, 2, 1. Second element and second element, 2, 2, and so on, right? This is how we try to find Cartesian product.
yes, sir.
Everyone, this is clear,
Yes, sir.
Yes.
right? Now, if they have given you that relation R is on set n cross n, so this is A for you, right?
Yes, sir.
So you have to find A cross A. Is this clear?
Yes, sir.
To find this, you have to write A 2 times. Is this clear?
Yes.
Everyone?
Yes, sir.
Now, what is A? A is n cross n. To find n cross n, you have to write n 2 times. And what is n? Set of all natural numbers. So this will be 1, 1, 1, 2, 1, 3, and so on. 2, 1, 2, 2, 2, 3, and so on till n, 1, n, 2, n, 3, and so on, right? Where n can be infinite. This is clear. What is set A here?
Yes, sir.
Yes, sir.
Now we have to write A 2 times. So again 1, 1, 1, 2, 1, 3, and so on. 2, 1, 2, 2, 2, 3 till this till n, 1, n, 2, n, 3, and this. Right? Now we have to find A cross A. So how do you find A cross A? To find A cross A, you take first element of this set. So this is 1, 1. Now the first element of this set. Now 1, 1. This is one ordered pair. Is this clear now what I am saying?
Yes, sir.
Yes, sir.
Now for the second element, you take the first element here and the second ordered pair here, second element. So 1, 1, 1, 2. And this will be your second ordered pair. And you have to calculate this till you reach the end. So in here, all the ordered pairs will be related to all these other ordered pairs. Is it clear now?
Yes, sir.
Now you have to look which of these ordered pairs, satisfy which condition this A comma B related to C comma D, such that what was this A plus D is equals to B plus C, right?
Yes, sir.
So in this ordered pairs, the elements are ordered pairs itself. That is why they have given you this. Ordered pair is related to ordered pairs, because in this set of Cartesian product, the elements are ordered pairs itself. So if you put 1, 1 related to 1, 1, is it true or not? So how you can prove this? Suppose I number this. This is 1, 2, 3, 4. So what is the in the equation? First element plus fourth element and second element plus third element, right? This you have to
Yes,
do.
sir.
So if this is the ordered pair, then first element is 1, fourth element is 1. This should be equals to second element plus third element. So 2 is equal to 2. This is 2. That means 1, 1, 1, 1 belongs to R. Is it clear now?
So the fourth element is A, right?
No, this is D. My handwriting is bad. That is D. All right.
Yes, sir.
Yes.
But if we take 1, 1 and 1, 2, then it's
Let's
not
see.
equal.
All right. Let's see. 1, 2. If 1, 2 is related to 1, is related to 1, 2, then what should happen? First element plus fourth element is 2 should be equals to second element plus third element, right?
Yes,
Ishan?
sir.
So we should get 3 is equals to 2, but this is true or not?
So it's not, because 3 is greater than 2.
So this is false. So we can say 1, 1, 2 does not belong to R. Is it clear?
Yes, sir. So this means it's not reflexive.
No. What is reflexive, Ishan?
That the pairs should be equal to themselves, related.
Right. If we can say A is related to A, right? If this is true for all A, then you can say this is reflexive. But in this case, what you can say, see, A is related to A. Whatever element is here should be related to the elements itself. So we can say if A comma B is related to A comma B itself, right? Because here the elements are ordered pairs themselves. So A comma B should be related to A comma B. If this is true for all A comma B, then this is reflexive. Is it clear or not?
Yes, sir.
Everyone, this is clear?
Yes, sir.
Yes. All right. Now, please try to solve this. All right. Again, it's okay if you cannot solve this, but if you do this, then congratulations from my side. All right. But think in pairs. Wherever you think in single digits, try to think pairs. All right. For symmetric, if A comma B is related to C comma D, then for this to be symmetric, what should happen? Anyone?
So A comma B should be related to B comma A.
No. Again, you are thinking in single digits. In here, ordered pairs are there in relation. See, if A is A are B, then in symmetric P are A, right? Whatever is written in the right side comes to left side, right? A comma B belongs to R, that means B comma A should belong to R. In here, instead of A, we have a pair. So if A comma B comma C comma D belongs to R, then what should happen?
B comma A and A
comma
comma
A
C.
and A comma C.
No. Again, you are changing the disordered pair.
Sir,
You
C
have to,
comma A and
comma D
Comma A
belongs
and
to
A comma B.
A comma.
right. Somebody answered this correctly. I think it was Syed. Everyone else was wrong. Syed, can you repeat the answer?
Yes, sir. C comma D belongs to R and A comma B belongs to R.
No. Why did you break this down?
So C comma D comma A comma B.
Absolutely
Right.
right. Absolutely. Ishan, absolutely right. So please buy one Kit Kat from my side. All right. I will see how to pay you. This is clear, everyone, because this and this is the ordered pairs. Everyone is clear about this?
Yes, sir.
Yes, sir.
All right. So always think in pairs whenever trying to solve this type of question. So do you want to try this, everyone?
yes, sir.
All right. I'll give you 5 minutes. Take your time, think about this, digest it properly.
Sir, can you solve this?
All right. Everyone wants this for me to solve this. Everyone. Is everyone okay after listening to this question?
Yes, sir.
Okay. If anyone wants to drink water, it's energy, then it's okay. All right. All right. Let's see. For this to be reflexive. All right. Let's think what should happen if this is reflexive. We know for something to be reflexive, A should be related to A. But in this question, A comma B should be related to A comma B. Right, Krishna?
Yes, sir.
So let's see. For reflexive, we can say let a comma b belongs to n. All right, a comma b belongs to n. This is clear. And
Yes,
a
sir.
comma b also belongs to n cross n. Right, this is an ordered pair, so this also belongs to n cross n. Now, can I say a plus b is equals to a plus b? Can I write this or not?
Yes, sir.
All right. So if this is to happen, what do I have to prove? First element, fourth element should be equals to second element plus third element, right?
Yes, sir.
So if I get this equation, then I can write this one. So how to get this equation? Very easy. A plus b already have. I can reverse this order. So this will be b plus a. This is clear, Krishna?
Yes, sir.
So if I have this equation, can I write this one?
Yes.
Yes or no? Right. So we can write a comma b is related to a comma b. Right. In here, one single element is this. So this element is related to itself. So we can say R is reflexive. Is it clear or not?
Yes,
Yes,
sir.
sir.
Okay, everyone,
Yes.
Syed?
sir.
Yes, sir.
All right. Note it down, guys. Then I'll solve for symmetric.
Done, sir.
Now for symmetric. Let a comma b and b comma c, sorry, c comma d belong to n cross n. All right. These are two ordered pairs which belong to n cross n. And let a comma b is related to c comma d. I'll always assume this, right? Let's think. Whenever trying to prove symmetric, we used to assume that a is related to b, and we had to prove that b is related to a, right?
Yes, sir.
We assume this. We had to get to this point. In this question, we have to assume the elements as ordered pairs. So we have to assume a comma b is related to c comma d, and we have to prove that c comma d is related to a comma b, right? Reverse the order. Is it clear or not?
Yes, sir.
Yes,
To
sir.
prove and to this means what equation should we get? Anyone can tell me what should I get?
So C, comma D, comma A, comma B.
No, that is right. But according to the question, what is the relation? If this ordered pair is related to this, then what condition should they satisfy?
So the condition mentioned is A plus D is equal to B plus, and it
Right. Right. So A plus B, that means first element plus fourth element should be equals to second element plus third element, right?
Yes, sir.
So this means first element here is C, fourth element is B, should be equals to second element is D plus A. Is it clear?
Yes, sir.
Yes.
So if we get this equation, then we can say this is true, and if this is true, then this is symmetric. So let's see if you can get this. We assume that let a comma b is related to c comma d. So from this we can write that again the condition first element is a, right? This is first, second, third, fourth according to the question, right? And this is equals to
uh, third C plus B. C plus B.
C plus b or b plus c.
So C plus B. First, B plus C. Second plus
C plus c. The order matters here. All right. Always look at the order. If the order is not correct, then everything will go wrong. All right. First plus fourth is equals to second plus third. So from here, can I say b plus c is equals to a plus d commutative?
Yes, sir.
So again, I reached not now. I have not reached to this equation. We have to interchange this also. C plus b. I can write this or not.
Yes, sir.
So now I can say that c plus d is related to a plus b. Is it clear?
Yes, sir.
Yes, sir.
So we assumed a comma b related to c comma d, and we proved that c comma d is related to a comma b. So is it symmetric or not?
It is symmetric.
So R is symmetric. Everyone, this is clear or not?
Yes, sir.
Yes.
All right. Ishan, Said, Shikani.
Yes, sir.
Yes, sir.
All right. Please note it down. And now try to solve for transitive yourself. I'll give you again 5 minutes. All right. Think about this. Don't worry if you cannot solve. It's okay. But try to solve. Anyone solve this?
So 2 minutes.
All right.
Sir, done.
Let's see how to prove transitive. See, in transitive, in the previous questions, we have to assume that a comma b is related to r and b comma c is related to r. Then we have to prove a comma c is also belongs to r. But in here, all the elements should be ordered pairs. So we can say let a comma b, c comma d, and e comma f belong to r, right? And we have to say and a comma b is related to c comma d, and c comma d is related to e
But it's
comma
very
f.
easy to solve it, so it's like basic. We didn't discuss it, right?
Sorry, Shikani, I'm not able to understand you. Everyone is clear about this? What I wrote here?
Yes, sir.
Where did E comma F come from?
Sorry?
Where did E comma F come from?
Right. Where did e comma f come from? C. In transitive, we had to assume this, right? Ishan, a comma b belongs to r and b comma c belongs to r. And we had to prove that a comma c also belongs to r.
Yes, sir.
Now, in here, how many elements did you need? 3 elements, A, B, and C, right?
Yes, sir.
But in this question, each of this element is a ordered pair itself. Right, Ishan?
Yes, sir.
So to prove something is transitive, you needed 3 different elements. But in this question, these different elements are ordered pairs themselves. So you have to assume 3 different ordered pairs. Is it clear or not?
Yes, sir.
Right? So we can assume as many elements as we want. So A comma B, C comma D, and E comma F belongs to R. Now see, this is, suppose this is P, Q, and R. I wrote the previous method only. P is related to Q and Q is related to R. Right? We have to prove P is related to R. That means we have to prove A comma B is related to E comma F. Is it clear?
Yes, sir.
All right. So to prove this, we have to get what statement? Can anyone tell me what should I write here? In here from this?
Sir, you assumed A comma B, E comma D, and E comma F, right? Then
No,
how
no, this
C
is
comma
C.
D?
C. This is C comma D. Again, my bad handwriting. All right. Clear, Krishna?
Yes, sir.
So from this equation, what should I write? If this is true, then
A plus F is equal to B plus C.
right. So if I get this statement, I can say this is true, and if this is true, then this is transitive. So from here, I can write A plus D is equals to B plus C, right? From this equation. And from this equation, I can write first element plus fourth element is equals to second element plus third element. This is clear, everyone?
Yes, sir.
Yes, sir.
All right. So suppose this is equation 1 and this is equation 2. If we add these equations, adding equation 1 and 2, A plus F, right? So if we add this equation, we will get A plus D plus C plus F is equals to B plus C plus D plus E, right? So C and C is cancelled and D and D is cancelled. So we have got A plus F is equals to B plus E. Is it clear, everyone?
Yes, sir.
So this is the same exact statement. So if we got this, we can say A comma B is related to E comma F. So R is transitive. This is clear or not?
Yes, sir.
Yes, sir.
All right. So write it down. Done, everyone?
Yes, sir.
Now, what is the
Yes, sir.
second part? They are asking you to find equivalence class of. Can anyone tell me what is the question? Equivalence class.
Set 2 comma 3 and set 1 comma 3.
All right. So what is equivalence class? We can write equivalence class of 2 comma 3 is all the order pairs related to 2, 3. All right. Equivalence class is nothing but this. What this means is, suppose you have given the relation R 1, 5, 6, 2, 7, 1, 7. All right, and 7, 1 and 5, 1. All right. You can check if this is equivalence or not. Suppose this is equivalence. All right, equivalence relation. Then if somebody asks, write equivalence class of 1, that means all the ordered pairs where 1 is there, all the elements related to 1. That is all. Nothing too complicated. All right. Write all the elements which are related to 1. That is the equivalence class. And 1, 1 is also there, and 2, 2. All right. Suppose that is equivalence relation. So this will be equivalence class. Is it clear, everyone? All the elements related to 1 will be in the set of equivalence class of 1. Is it clear or not?
Yes, sir.
All right. So in here they are asking equivalence class of 2, 3. So all the elements that are related to 2, 3 will be in equivalence class of 2, 3. So how we can find Lect? So this implies from here, this implies as all x, y who are related to 2, 3. Is it clear?
Yes, sir.
So if this is true, then what we can write? X plus 3 is equals to y plus 2. This should be true if they are related. So in here we can solve this equation. X minus y should be equals to -1. So this is the equation you got. So equivalence class of 2, 3. Just put the value of x and y as natural numbers. So if x is 1, then y have to be 2. 1, 2, 2, 3, right? Just increase 1 and so on. This is the equivalence class. All of these elements will be related to 2, 3. Is it clear or not?
Yes, sir.
Everyone?
Yes, sir.
All right, note it down and solve for the other one also. 1, 2, I think. Let's solve for that also. Done, everyone?
Yes, sir.
Like this is clear, right?
Yes.
Anybody has any doubt on this? Ishan, Syed, Ronaldo?
No, sir.
No, sir.
No, all right. So I hope this question is clear, and please complete today's assignment. That will be very crucial. I'll do 3 types of questions only. All right. So please solve this and ask me any doubts in the next class. All right, everyone. This is all for today's class.
Sir, assignment will contain these kind of questions.
Right. What will be given today will contain this kind of questions. So please solve that. All right.
Okay.
Sir, where will be the assignment given?
In the portal, right? Everyone gets that assignment in the portal, I guess.
Sir, I'm not in any portal.
Learnivio website. That is the portal, Ishan.
I will ask them, sir.
All right. You can contact the team. If not, I'll also tell them to send you the assignment. All right, Ishan.
Sir, I don't have your contact information.
You have no contact information also. All right, don't worry. I'll ask my team to contact you, and you will get the assignments on WhatsApp. All right, and you can send them the answers on WhatsApp also. All right.
Yes, sir.
All right, then take care, everyone. This is all for today's class, and please revise and complete the assignment. All right.
Okay, sir.
Thank you.
All right, then see you in the next class.
Thank you, sir.
Thank you, sir.
All right.
Thank you, sir.
All right. Shifani, we are just ending the class. I was just asking the students that please complete the today's assignment. All right, Shikani? Shikani, I'm still not able to hear you. You can reply on chat. All right, this is all for today's class. No issue, Shikani. We